Hey, what's up, guys? Nick White here. I do tech and coding stuff on Twitch and YouTube, and I am coding a lot and stuff like that. Okay, so yeah, this one is called merge to sorted linked list. Description has all my information. Freaking go check out the playlist on my channel. Okay, this is merge to sorted lists. So I've done this on LeetCode. We're merging two sorted lists, if you haven't guessed it by now. You're given the pointer to the head nodes of two sorted lists. So we have the heads. If we have two sorted lists, we have the heads of them. The data in both lists are sorted in ascending order. So maybe it's like one is 1, 2, 3, and one is 4, 5, 6, right? They're ascended order. Change the next pointers to obtain a single merged linked list, which also has data in ascending order. Either head pointer may be given, maybe null at the beginning of the array. Okay, so either head pointer might be null, meaning one of the lists doesn't exist, right? So first we'll just check for that. If one of the lists doesn't exist, so if head 1 is null, we'll just return the other list, right? Because it's already sorted in ascending order. So if head 1 is null, return head 2. If head 2 is null, return head 1. That's easy. Okay, now what do we want to do? How do we do this? So you might think, well, oh, one of them is 1, 2, 3. And one of them is 4, 5, 6. Well, I'll just freaking go through the whole first one and then point the last element to the first element of the second one. Well, that's wrong, because one of them can also be 1, 2, 3. And well, look at that. Would you look at that? That would return 1, 2, 3, 1, 2, 3, and that would not be sorted, right? So what we actually have to do is we're going to loop through them simultaneously, node by node. So if we had 1, 2, 3, 1, 2, 3, we are going to loop through both 1, 1, 2, 2, and 3, 3 at the same time, do checks, and put the smaller in. So in this case, it doesn't really matter which one we put in. We're just going to put an arbitrary one in because they're the same values. But, you know, if we were looking at, 4 and then 8, 6, and then 1, 4, 6, and then 2, 5, 7, then we would do, put 1 in, and then we'd put 2 before we put 4 in, and then we'd put 4 before we put 5 in, and then we put 5 before we put 6 in. So you pick the smaller of the two elements, right? So that makes sense. So we're going to need a new list, and then we're going to loop through both of these and append to the new list. Okay. So what's the head of our new list going to be? Well, the head, let's just say it's null right now. So we'll call it head 3 because we got head 1 and head 2 for the other one. So we'll just say null. Now to choose the head, we're going to have to do this check, right? If head 1.data is less than head 2.data, well, then the head, we want the head to be the smallest element because it's sorted in ascending order. So head 3 is going to be head 1, right? And head 1 will be head 1.next. Because you always have to keep looping through those nodes. Else it's just the other case. I'm sure you might have guessed by now. Head 3 will just be head 2. And head 2 will be head 2.next. Pretty easy. Okay, now here's the main loop. While both of these pointers are not equal to null. So while head 1 is not equal to null, and head 2 is not equal to null, then that means that we're able to simultaneously compare nodes and put the smaller value in. So it's pretty much the same conditions up here. If head 1.data is less than head 2.data. Oh, and also what we need is we need to keep reference to the head of our new list, right? Head 3 is our new list head, right? So to keep reference to the head of our new list, we're going to just leave head 3 there and have a current node point to it, right? So we set current node to head 3, and then we'll use current node to actually set the next values in our list, and then we'll just return head 3 at the end, right? So at the end, we're just going to return head 3. That'll be the head of our new list. Current node will actually set the next values for us. So we're going to do, if head 1's smaller, we're going to do current node dot next is equal to head 1. And then we're going to do head 1 equals head 1.next, just like how we did it up there. We have to keep moving along the lists. And it's the same thing for, head 2. Right, pretty easy. So that's pretty much it. And then you also have to make sure you increment your runner node. So current node equals current node.next at the end of each loop. Now the only thing you have to account for in this problem is that this loop will break when one of the lists hits null first, right? So the lists don't have to be the same size. So when one of the lists runs out, obviously we just have to add all of the values from the other list, right? So you know, the rate when the lists break out, well, we're gonna assume they're the same size probably in this one, but they don't. In other ones, they don't have to be the same size. But like, when they break out, it's gonna mean that head 1 is either null or head 2 is either null. So we just have to check if head 1 is equal to null, then well, that means that we're gonna add head 2 as the last node, right? And that'll be fine even when they're differing lengths, because if you just point it to the head, it'll have the rest of the nodes anyway. And then we just do head 2 equals head 2.next. You don't even have to do this, honestly. I would just say point it to the head node. Else current node.next is equal to head 1, right? Because head 1's not null in that case. Okay, that's it. So that should be good. Hopefully that makes sense. Maybe I'll explain it one more time. There we go. We passed all the test cases. Let's go. So you loop through the list simultaneously. You have a new list. You create a new list. You loop through both of them simultaneously. You check which values are smaller, obviously, as you go through. And the smaller one goes into the new list because it's going to be sorted in ascending order. So you want the smallest to largest, right? Ascending. And then when you break out of the loop, you just have to find, you know, which list doesn't have null nodes still and append the rest of those nodes, because that's going to be ascending and it's going to work out perfectly. Hopefully that makes sense. This is easy, pretty intuitive, but it is a little more tricky than the other easy ones we're doing. So, you know, that's pretty much it. So let me know what you guys think, and check out the next video. I'm just going through all of them, so check out the next one. See ya.